So guys, in this episode, I just want to take you through what I call a background check to see if you know some of this stuff and for you to also assess yourself and see if you know some of the very basic stuff. Guys, first of all, I want us to look into the matter of notation. Very important. Notation. Notation in mathematics is almost everything because for someone to read what you have written, you have to use the correct notation, especially if you want to be understood. Okay, so first of all, functional notation, guys, the very basics. Okay, I know you know this. Okay, if I say f of x is equal to 2x plus 1, for example, another way to say this, I can say, well, f such that x is being mapped into the following rule, 2x plus 1. Now, this is one of the questions that confuse students, and you will see why I thought I should talk about notation. And you will see also why as we discuss first principles later on. Okay, there's a question, for example, I will give you, let me take the same f of x. I'll give you a function and say, f of x is 2x plus 1. Then I'll say, find, okay, the value of a if, okay, or let me say such that, let me just continue, such that f of a is equal to 2. And this is where the problem starts. Now, what is happening on? You see, the simple solution to this is just use the rule. F of a is 2a plus 1. Now you are told that f of a is 2. So 2 is equal to 2a plus 1. Therefore, I can't do this algebra for you. You should know by now. A should be 1 over 2. Okay, that's it. Here's another one. Also, one of those things that really I've seen it tricking students. Find, listen to this one, k such that f of k is equal to k minus 2. Okay, that's it. Then again, students will say, what is going on here? Just wanna again say to you guys, you gotta keep calm and go with the drill. First of all, find f of k. This is 2k plus 1. Now, what should this be equal to? It should be equals to k minus 2. So therefore, 2k plus 1, you have to solve for k in this equation. And you can see grouping like terms, k is minus 3. Okay, because you got to take that. And you can always test this. You can always test this and see if you will get the same thing. You can see if you put a minus 3 there, you're going to get a minus 5. If you put a minus 3 there, you're going to get a minus 5. So your solution is valid. So this is one critical thing that I wanted to pass through. Finally, the other thing that I want to talk about is factorization. I know it's something that you've done and you will say, really, sir, and all that. And I'm telling you, Mr. G knows exactly what you guys struggle with. I've seen it, so take advice, right? So here we go. Let me just write this one. And I'll just say factorization tips. So a tip is not something that you're forced to take. You can just decide if you want to receive the tip or not. And this will appear, especially when you deal with limits. You will see in some of the exercises that you guys will have from your textbooks or so. And even when you solve the final exam paper. First of all, guys, we know the difference of two squares. I've used a lot. So let me just use x and y. right? You know that this factorizes into x minus y, x plus y. That's one. Then you also know the sign change. If you have x, not x minus y, if you have y minus x, so in this case you have y minus x, and you want to write it as x minus y, then you know you're just going to take a -1 out and you have x minus y. This is very important, okay? Then another one, guys, I have spoken about this. I hope you know how to square a binomial without having to FOIL. Okay, in other words, without having to expand the brackets, you must know, okay, this is just a squared, multiply those two, and then keep the middle sign, and then put a 2 next to that. And then, of course, this is going to be a plus. You square that sign, and then you have that, right? Again, the other one that you should probably know is that if you have plus, in the case of plus, then everything is just a plus, okay? A squared plus 2ab plus b squared. The last two, which you also know, but I think will play a very important role now that you're going to do with cubic functions, is the sum and the difference of two cubes. So let's start with two cubes. I found myself using a and b. I guess I like a and b so much, it's fine. So this, you know, first of all, you're going to have a minus b. Now here, you know you're going to have an a squared there, you're going to have a b squared. Now what you do to get the middle term, you say, okay, what is a times b? It's ab. And now what is the opposite of this sign? It's a plus. So you're going to have a plus ab there. That's what you're going to have. And obviously, this one, you want to have a plus. Okay, so that's how you factorize the difference of two cubes. The last one, guys, is the sum of two cubes. And if you have a plus b, first of all, you're going to have a plus b, and you know this is going to be a plus, and that's going to, I mean a square, that's also going to be a square. And in this case, again, multiply ab, opposite sign is a negative, and obviously that one will be a negative. So as you can see, the only difference in factorizing these two is that thing there, okay? And it's just that these signs should be opposite. Okay, that's the key thing for you to note there. Let me close off by giving you an example, right? Suppose you have to find the limit of a squared minus 1 over a minus 1 as a approaches 1. Okay, this is an example. Then you see if you substitute, you're going to have a problem. You're going to have to divide by 0. So you don't want to divide by 0. So what you'd rather do, you'd rather say, okay, this is equals to the limit as a approaches 1 of, you see that's a difference of 2 squares. You see why I just gave you those tips, over a minus 1. And you can see right away the best part that you guys like. This is the limit of a plus 1 as a approaches 1. And this is actually equals to 1 plus 1, which is 2. So the limit is actually 2. In other words, if you were to draw this function, you will see that as values of a approach 1 from the left and from the right, the y value that is being approached is actually 2, or the y value of the function at that point is actually 2. All right, you may want to now try the rest that you can come across in your exercises and so forth. But as for me, I am done introducing the limit, the concept of a limit. In our next video, we are going to discuss the average gradient. Cheers, guys.